This is 2016 AMC 10A, number 24. Okay, so now let's figure out the figure, right? How it looks like. So we have a circle 202. This was just circle 202. 200 red 2. But we have quadrilateral. The side, each side is 200. Okay, three sides. Okay, not every side. 300, 200. So how it looks like it? Okay, you have to figure out. So maybe you can try. You can test this. We have right three triangle we can make right there, or equilateral triangle, isn't it? Equilateral triangle. Okay. So this side also at 200 red 2. This also 200 red 2. Okay. 200 red 2 is what approximately 200 times red 2 is approximately 1.4. 280. Okay. So 200 actually much less than these numbers. So the actual figure looks like this way. I'm gonna make it okay, fine. If I have diameter over here, okay, the red is 200 red 2. This length is 200, very small, right? So from here to here, maybe you can make the line from here to here, right? This is 200. Okay, this is 200. So another 200, another 200. You can make it small. Okay, yeah. Okay, now right, I'm gonna make it small. Okay, very this is 200. This is 200. This is 200. Looks better, right? This last side should be up here. It can be equal, right? This diameter. Okay. So each side is 200. Very big number. Okay. All right. What is the third side? This side is x. I'm going to use different side. Okay. I'm going to use this one later. Okay. Yeah, this side is x. Fine. Okay. Three sides is given. Maybe we can try to use what Ptolemy's theorem, right? You know the Ptolemy's theorem? When you have quadrilateral inside, okay, cyclic. This is a cyclic. You inscribe the circle. This is A, this is B, this is C, this is D. We have two diagonal, right? This is diagonal 1, this is diagonal 2. Ptolemy's theorem looks like this one. Opposite side product, the AB plus the other one is CD. Sum of this one should be equals to what? D1 times D2, right? They're always equals. Okay, this is Ptolemy's theorem. We can apply this one. Okay, all right. Now let's find out diagonal. Where is the diagonal? This diagonal, isn't it? The other diagonal is the same length. This diagonal, this is actually isosceles. All right, so from here we gotta find the length of diagonal. Maybe you can find what half of this one. When you're over here, that is 202. This same length. Okay, we're gonna find this length. Okay, after that you can make twice. Okay, not that job. Okay, but the problem over here, we have a very big number over here, 200, 200, 200. So we can use a little downside. Okay, the symbol number. Okay, maybe you can divide it by 100. Maybe this one is 2, this is 2, this is 2 red 2. After find the y x, now you can multiply 100 again, right? That's why you have very good mathematics skills. Okay, all right. Now use this one. I'm going to use 2. Okay, after that you're going to keep this number 100. Later you have to multiply by 100. Okay, times 100. Okay, to find this one, we have another line over here. Okay, all right. This is what 202. 2 red 2. I'm going to use 2 red 2 right now. This is 2 red 2. I'm going to use the x later. Okay, I'm going to take this as x. But the other side, how much? 2 red 2. 2 red 2 minus x. Is it? And also what? This angle is 90 degree, right? Because when you have a chord, any chord over here, Okay, when you make the line perpendicular over here, okay, perpendicular, always these two sides is equal. Is it okay? Yeah, because this is what same number too, right? This is the same. Okay, this is equal. This is equal. This diameter always perpendicular to this was chord. Okay, so this is the right angles. Now these two right angles, we're gonna find the value of x. Okay, first of all, we're gonna find the length of this one in two different ways. The length of this one. From this side, from this triangle, we can find square root. What is that? Hypotenuse square. That is 4 minus x square, isn't it? Square root. Okay, and the other side is what? Square root. This one hypotenuse 2 right 2 square minus this is square, right? Okay, 2 right 2 minus x squared. Yeah, they must be equal, right? Okay. Actually, we don't need to write out the radical side, okay? Now simplify. 4 minus x squared. Inside it must be equal. The square of this one is what? 2 right 2 squared is 8. Square over here, 2 right 2 is what? Square is what? 8 again. And inside is what? 2 right 2 times 2 is 4 right 2, right? X and plus x squared, isn't it? Okay, that's fine. So x squared is x squared out. You can see that. X squared out. This is minus x squared, okay? 8 and 8 is out. How you got this one? 4 equals plus minus is what? Plus 4 right to x. From here, x is how much? 4 over 4 right 2 over 1 over right 2, isn't it? X equals 1 over right 2. This is the value of this one. But we need this length, the red line, okay? Now find out again. So anyway, this is y. Half of this, okay? So y equals how much? Square root 2 square again, 4 minus x squared again, 1 over 2, right? This is what? 7 over 2, isn't it? The simplified error use this one times 2 times 2. That is square root 14 over 2, right? That is the value of y. Okay, we are done, right? It's very quick. So, all this diagonal, how much? The length of this diagonal is 2 times, that is square root 14, isn't it? Square root 14. It's okay? The other diagonal, the same length, that's symmetry, okay? 14. So, this is now, I'll take this is a large x, okay? Large x. So, sum of what? Product, opposite side, okay? Using what? Ptolemy's rule, okay? 2 times 2 is 4, plus 2 times x is what? 2x. That is equals to diagonal, right? Red 14, same diagonal times red 14. Okay, this is Ptolemy's theorem, okay? Alright, now let's find the value of x. 4 plus 2x equals 14, right? From here, 2x equals 10, x equals 5. Okay, we had a downside number, okay? Now, to get the real number times 100 again, okay? The real number, real x should equals 5 times 100, okay? 500 is the answer, okay? That's fine. This is not hard, okay? Usually, geometry and AMC is easier than algebra, okay? Okay, that's it, okay? Okay, thank you. See you next time.